Okay, this is section 6.3, exponential growth and decay. Here's a formula. This whole section is going to be a matter of plugging into the formula. Exponential growth is when you're increasing in value. Exponential decay is when you're decreasing in value, and the best example of that is depreciation on your car. In this formula, A equals P quantity 1 plus or minus R to the T power. A is the end cost or price. P is the principal or the original amount. R is the percent rate of change. We're going to write that as a decimal, so be real careful. That's a place for error. And then T is the time. So all we're going to do is plug and chug. You're going to need a calculator here. We're going to use some pretty large exponents that won't be fun if you have to do them on paper. So number one, I bought a car in 2004 and it cost $15,000. Depreciation of cars is about 12% per year. How much was my car worth in 2011? So that's 7 years. So A is equal to, my principal is 15,000 times 1, and it's depreciation, so we're going to subtract here. So subtract 12%, which is 0.12, 1200ths written as a decimal, and that's 7 years, so to the 7th power. So your calculators may round in a different place, but I'm going to show you what mine did, and you're going to see why you need a calculator here. So remember to do what's in the parentheses first. So I have 8800ths to the 7th power. Once you take 8800ths to the 7th power, I get this decimal. And it's great if you could just leave this in your calculator and then multiply it by 15,000. And I'm going to say about the squiggly equal signs because I rounded to the pennies, the cents. So 6,130 and 14 cents. Okay. Number two, the population in India is growing. This is exponential growth at about 3.5% a year. If the population was 5 million last year, what will the population be? And let's change this to 2020. These are getting old. Let's change it to 2022. Okay, so we have 500 million times 1 plus 0.035 or 35 thousandths, and I'm going to say 2 years. Okay. So I have 1 and 35 thousandths squared. These come out a little nicer than usual. The decimal I got was this. And when I multiplied, the population of India is 535,612,500. And again, that's about approximately. Let's put people. Alrighty, the next one. Let's say you decide to go to college and you want to become an actuary. That's a really good job. Actually, someone who figures out insurance premium, tons of math in that job. Your starting salary will probably be around $65,000. If you are guaranteed a pay increase of 2% per year, how much will you be earning in 12? So that's growth. So we're going to take 65,000 that you start with, and we're going to make that 2% into a decimal. And then your time, we said 12 years. Again, we're going to go inside the parentheses first. I get a longer decimal this time. Bear with me here. That's why I just leave it in the calculator and multiply by my principal. And when you multiply these together, you get approximately $82,435.12. That would be your salary. All right, our economy is in turmoil. Yes, I know you know this fact. If you invest $5,000 in mutual funds, chances are that you will lose about 1.3% per year. I really don't know if that's true anymore. So after 5 years, how much money will you have? So you're losing, so this is a decay problem. So make sure instead of using that addition, you're subtracting. So 5,000 is my principal, and I have 1 minus 13 thousandths to the 5th power. So when you subtract when you subtract 13 thousandths from 1, you get 987 thousandths, and that'll be to the 5th power. And I get this lovely decimal, so bear with me. Normally, I wouldn't even write this down. I would just leave it in my calculator, but you guys need to know. And when I multiply by the 1,000, and I lost some, I would be at about $4,683.34. And again, this is an estimate because I rounded. Again, this is a matter of plugging things in. We're going to do one more like this, and we're going to go on to something else. Number 5, you have a fantastic job in technology. You are making $95,000 a year, and you receive a 35% raise each year over the next 3 years. How much will you be earning? Well, that's like unheard of. That would be amazing. So you have 95,000 that you start with, and you have 1 plus 3,500 for 3 years. So 1 and 3,500 cubed is this decimal, not too terrible. And when you multiply that out, you would be making $233,735.63, and that's approximate because I rounded. That's of dollars. Okay. All right, I want to show you one more thing, one more application of growth and decay. This is compound interest. This is it's related, and it's how you figure out interest earned over certain periods of time, like days or weeks or months. This is tiny. Here's the formula: A equals P times the quantity of 1 plus the rate over the number of times compounded per year. The number of times compounded a year times the year's power. So again, you just got to plug things into the right place. So let's start with number 1. If you placed 4,500 in a savings account that was earning 2% interest compounded monthly, that means 12 times per year, how much money would you have after 5 years? That means they're going to add that interest to your account every month so that the interest you made is part of the interest they figure the next month. Okay, so I have A equals $4,500 times 1 plus the 2% divided by 12, because that's 12 times compounded. 5 times 12, 4. So let's go inside those parentheses first. I'm going to take 2/10 times 12 plus 1, which will give me this lovely and then 5 times 12 is 60th. So again, now you're going to want to take this to the 60th power. And I don't think you want to do that on paper, so you're going to need a calculator. When you multiply those two together, you get about $4,972.86 after 5 years. Okay, number 2, I invested $10,000 at the rate of 5% compounded quarterly. That's 4 times a year for 10 years. What's the value of my investment now? So we're going to use that 10. 5A equals that 10,000 initial investment. So we have 1 plus 5%, which is 0.05, and that's compounded quarterly or 4 times a year for 10 years. Oops. Okay. So let's deal with the parentheses. If I divide 500 divided by 4 and add 1, I get this. Oh my Lord. All to the 40th power. When I take it to the 40th power, I get this. And when I multiply those two together, after 10 years, it's pretty good. You get about $16,436.20. Okay, we have one more. Tyler is going to invest all of his lawn mowing business from this summer, the money he makes. Let's say he finds an outrageously excellent savings account that earns him 9% compounded weekly. That's 52 times a year. How much money will he have after 3 years? He puts in 5,000. So here's what we have. That's 9%, compounded 52 times. And then he's going to put it in there for 3 years. When I figure out what's in the parentheses, this is my number. So much easier just to leave it in the calculator. And 52 times 3 is the 156th power. Again, wouldn't want to do that on paper. So I come up with this. When I take this to the 156th power, and then when I multiply that out, he will end up with $6,548.29 after 3 years. Okay, that's it.